Hi, I'm Anna, and welcome to the D1 Audible Cheat Sheets. Let's begin where all wine begins, not in the cellar, not in the glass, but in the vine itself. There are over 1,000 known grape varieties in the world, but almost everything we drink as wine comes from a single species, Vitis vinifera. This species is native to Eurasia and has evolved to produce fruit with the balance of sugar, acidity, flavor compounds, and tannins that make fine wine possible. Other vine species exist, particularly North American species like Vitis labrusca, Riparia, Balanderi, and Rupestris. But globally, their most important role is not fruit, it's survival. These species are used primarily as rootstocks, providing resistance to pests like phylloxera and helping vines adapt to different soil and water conditions. So, already one key cause effect link to lock in. Vinifera gives us wine quality, American species gives us vine resilience. Now, let's look at the structure of the vine itself, because understanding this explains almost every vineyard decision you'll meet later in D1. All vines share the same basic anatomy, which can be divided into four parts: the shoots, 1 year old wood, permanent wood, and the roots. Together, the green parts of the vine, the shoots and everything attached to them, form what we call the canopy. And canopy management is at heart about controlling how the vine grows, ripens fruit, and responds to its environment. Each spring, shoots grow from compound buds that were formed the previous year and retained during winter pruning. These shoots are the vine's engine room for the growing season. Along each shoot are nodes, the point where leaves, tendrils, buds, and grape bunches attach, and the internodes in between. The main axis of the shoot transports water, nutrients, and sugar, and also acts as a carbohydrate store. As the season progresses and temperatures fall, those green shoots lignify. They harden, turn brown, and become woody. At that point, they are called canes. This matters because winter pruning decisions determine exactly which canes and therefore which buds will form the following year's crop. Buds are particularly important for yield and fruit quality. Compound buds contain the entire next season in miniature: stem, leaves, tendrils, and often inflorescences. Each compound bud usually contains a primary bud and a smaller secondary and tertiary buds. If the primary bud is damaged, for example by spring frost, the secondary or tertiary buds may grow instead. The cause and effect here is critical. Primary buds tend to give more predictable yields and better fruit. Secondary buds are insurance, but often less fruitful or uneven. Prompt buds behave very differently. They form and grow in the same season, producing lateral shoots. Lateral shoots are thinner, smaller, and are essentially the vine's backup system if the main shoot tip is damaged. They can contribute additional leaf area for photosynthesis, which can be helpful near the ends of shoots where light is good. But laterals closer to the base of the shoot often cause problems. They restrict airflow, increase shading, and raise disease pressure. That's why summer pruning may remove them, not to reduce growth, but to improve fruit exposure and vineyard health. Some varieties, notably Pinot Noir, often produce inflorescences on lateral shoots. This leads to what's called a second crop. These bunches ripen later than the main crop, So, if harvested together, they're typically higher in acidity, lower in sugar, and in black grapes, lower in color and tannin maturity. If machine harvested, this second crop can dilute the must and reduce overall wine quality. If hand harvested, growers can leave it behind or separate it. So, again, harvest method directly affects whether second crops help complexity or harm balance. Tendrils are simple but essential. The vine cannot support itself, so tendrils allow it to cling to trellising. In wild vines, this meant climbing trees. In vineyards, it means structured canopy positioning. Even so, growers don't rely on tendrils alone. Shoots and canes are usually tied to ensure stability and uniform exposure. Leaves are where the real work happens. They are the site of photosynthesis, producing sugars that fuel vine growth and eventually ripen grapes. On the other underside of leaves are stomata, tiny pores that regulate gas exchange and water loss. When water is plentiful, stomata stay open, allowing carbon dioxide in and photosynthesis to proceed efficiently. Under water stress, stomata partially close. This conserves water but limits photosynthesis, slowing sugar accumulation. This is a foundational D1 link. Water stress doesn't just reduce growth, it directly slows ripening. Inflorescence are clusters of flowers that, after flowering and fruit set, become bunches of grapes. Most shoots carry 1 to 3 inflorescences depending on variety and growing conditions. Not all flowers set fruit, which is why bunch size and compactness vary. Some varieties, such as Pinot Noir, naturally form very tight bunches. Tight bunches restrict airflow and increase the risk of fungal disease, especially if skins split during growth. That's why canopy management and site choice are especially important for these varieties. Each grape is a berry made of pulp, skin, and seeds. The pulp contains water, sugars, acids, and some aroma compounds and is usually colorless. The skin is where most of the color, tannins, and aroma precursors are found, especially in black grapes. Seeds contain oils and tannins, and their maturity affects tannin quality during winemaking. A waxy coating called the bloom protects the grape, and the stem attaching it to the vine contains tannins that can influence wine style if included during fermentation. After harvest, everything above ground that grew that year becomes 1 year old wood. This is crucial because compound buds, the source of next year's shoots and crop, are found only on 1 year old wood. Depending on pruning style, this wood is retained either as canes or as spurs. Older than that is permanent wood, the trunk, and in many systems, horizontal arms called cordons. Permanent wood supports the vine structurally, transports water and nutrients, and stores carbohydrates that fuel early spring growth before photosynthesis resumes. Below ground are the roots. Roots anchor the vine, absorb water and nutrients, store carbohydrates, and produce hormones that regulate growth and ripening. Most roots are found in the top 50 centimeters of soil, but in some conditions they can extend several meters deep. Root distribution is shaped by soil type, irrigation, cultivation practices, and critically, the choice of rootstock. Modern vineyards are almost always planted using cuttings, often grafted onto rootstocks. This allows growers to select rootstocks for pest resistance, vigor control, drought tolerance, and soil compatibility. Nurseries also treat and test cuttings to reduce spread of disease. Layering is an older method used mainly to replace missing vines. A cane from a neighboring vine is buried until it roots, then separated. The new vine grows on its own roots, which means no phylloxera protection and no rootstock benefits. Useful in some situations, but risky in many regions. Both cuttings and layering produce vines that are genetically identical to the parent plant. But over time, random mutations occur. Most are insignificant, but some change berry size, skin thickness, yield, or disease resistance. When growers deliberately propagate vines with desirable mutations, this is clonal selection. Pinot Noir is a classic example. Clone 115 produces small berries and low yields, making it suitable for high quality still red wines. Clone 521 produces larger berries and higher yields, making it better suited to sparkling wine, where color and tannin extraction are less important. So, clone choice is not about better or worse. It's about matching the wine behavior to intended wine style. For decades, clonal selection dominated, but many growers are now returning to mass selection, where cuttings are taken from the best performing vines within a vineyard. This increases genetic diversity, can enhance complexity, and reduces uniformity. But it is time consuming, labor intensive, and risks spreading disease if not carefully managed. New grape varieties are created from seeds through cross fertilization. Crosses occur between vines of the same species, hybrids occur between different species. Pinotage, for example, is a cross of Pinot Noir and Sanso. Vidal is a hybrid, combining vinifera with American parentage for greater resilience. Modern breeding aims to combine quality with disease resistance and climate tolerance. Genetic markers now allow scientists to identify promising offspring before vines even bear fruit, speeding up development. And yet, new varieties rarely reach the market, not because they don't work, but because consumers resist unfamiliar names. And that brings us full circle. The vine is not just a plant, it is a system shaped by genetics, environment, and human choice. Every decision from species stock, clone to pruning sets limits and possibilities long before fermentation begins. That's the foundation. Everything else in wine production builds on this. I hope this helps, and I'll see you in the next episode.